let's talk about module 2 and talk about, we covered a general infrastructure. Let's talk about some developer stuff around AWS. So this is going to be about getting started, a few of the developer tools, some of the management tools, and just kind of a little foray into things you probably need to know as a developer on AWS. So first thing to know is that, like any system, the first thing that has to happen is you have to get a login. Either you create it or someone gives it to you. General rule of thumb is that if you create logins for somebody, try not to get any information about the user. In other words, try to keep the user information specific to the user. Don't grab access and secret keys. Allow the user to get them themselves. If you need a portal for that, you can figure it out. But the first thing that happens is that you're gonna get credentialing of some type. There's two general types of credentialing inside of AWS, and everyone should take this in. There's a username and password for the web console, and then there's a what they call an access key and a secret access key for programmatic access. That includes the command line or code access. So just be clear, username and passwords are only for web console access. You cannot use them for programmatic access, and access keys and secret access keys are only for programmatic access. You can't use them for web console access. If you want to see this, let's say we go take a look at my account really quick. So we go like to IAM as an example. You can see, by the way, in the upper right-hand side that I'm actually logged in as Spartan Sage, which is what my son calls me. And my account's called M Forrester because that's my demo account. I'm in an IAM, which is actually the service that does user management for AWS infrastructure access. Here, if we go into here under users and we click on Spartan Sage, what will happen is that you'll see, for example, that I have obviously administrator access on this particular account. Here's some groups, right? Here's some tags. Well, I don't have any tags. Here's some security credentials, which includes things such as the console password, which you may have seen me sign in earlier with that. And then notice here's some access keys, of which you can have 2 active at any given time. And I have 1 listed here. There are other credentials, keys for code commit, get credentials for code commit, key spaces. There's also what they call key pairs, which are used to log into virtual machines. Key pairs, by the way, exist in EC2. They don't exist on a per user basis because key pairs are machine specific. So just be aware that when we talk about key pairs for logging into an operating system, that's a different thing because that's operating system specific, that is machine specific. Everything else here is specific to my user ID, particularly the Spartan Sage user on this account. Now you may see there's a user ARN there. The ARN stands for Amazon Resource Name. Notice it says ARN, AWS, because I guess there's Amazon ones. I don't know. Service. Then there's a blank space here, which I'll talk about that in a second. And then there's the account number, and then there is the particular object, which is a user/Spartan Sage, not group/admins, user/Spartan Sage. Be aware that an ARN exists for every single resource that you create in a service in AWS. If you create a table in DynamoDB called, cat table, it's going to have an ARN. You create a security group, it has an ARN. If you create an S3 bucket, it has an ARN. If you create an RDS database, it has an ARN. The Amazon resource name is the quickest identifier to get to a resource inside of AWS. But the main reason for coming here was just to mention that there was a console password and that your access keys are your main keys for getting programmatic access. Now you might say, Michael, where do you stick that at? Let me open up Git for a second. Or sorry, Git bash. You may notice that it says here that this key ends in a P, a B, an O, and an H. If you use, for example, the AWS command line, which I'm going to blow this way up so you can see it. Like here is me describing all the instances that I have in Ohio, which I don't actually have. If let's see, I change that to US West 2, which is where I'm currently running this stuff for the demos today, right? Notice that this is all in West 2. This is actually a dev on AWS environment that I started just for the class today. And notice that this is now showing up describing instances. That was the AWS command line. That's a tool you can install on Mac, Windows, and Linux. It uses the access keys and secret keys from this profile. How do you know that? Well, if I type in AWS configure, assuming I can spell configure, notice how it ends in PBOH. Notice how this ends in PBOH. By the way, I can also do interesting things here. And by the way, they're not going to show you the keys because, right, that's a security problem. I might just go ahead and change this actually. And I'm going to keep YAML. By the way, if you don't see YAML as an option for your output formats, it's because you're using an old version of the AWS CLI client. So just update it to the latest version. 2. something gives you YAML as an output. So now you saw earlier that when I ran describe instances, it was defaulting to Ohio and I didn't have anything running there. But now if I run describe instances, since I changed it, it's now going to list Oregon because I just changed it to Oregon. The whole point of that though was not to show you that these commands can be run and all that other stuff, was to mention is that these access keys are what give you programmatic access to AWS. In other words, if you want to function either from code or from command line, you have to use these access keys inside your user profile to get access. And there's 2 components to them, basically a username, which is the access key, and a password, which is the secret access key. Notice here that if I create an access key, what's going to happen is it's going to show the username, which is the access key ID, and then it's not going to show the secret access key. Now I can download this in a CS file, or I can show all of you, hi, look, there's the secret access key. And now it's on video so everybody can see it. But know also that immediately you can actually make this inactive, and then immediately I can delete it if necessary, right? And you just have to like copy or paste or type or whatever the key in there, hit delete, you're done. Okay. But that secret key, the access key and the secret access key are the 2 components that make up programmatic access. Now, once you get the access key and secret access key, you install it in your development environment. This can be done inside of VS Code or whatever you're using. And then install an SDK for your language so you can import one for Python or whatever. If you're ever looking for an SDK, by the way, you can always just go to AWS development tools, if I remember correctly. Oh, is it here? Hold on. Oh, here it is. It's /tools. So it's Amazon, aws.amazon.com/tools. And then what this will do is this will show you the languages that they have a variety of resources for. If you scroll down, by the way, it'll show you different command line tools and other things that they also have access. All of their tools are typically listed here that you can actually get access to. But notice here that they've got C++, Go, Java, JavaScript, .NET, C#, right? Node, PHP, Python, and Ruby. Anything else, there's probably somebody who's written some kind of kit for, but you're gonna have to manipulate that yourself. Okay. And then you just set up your AWS credentials. But here's the cool thing. I just want to mention this. Once you set up the AWS command line, typically all of the SDKs will use the command line setup. So you only really have to run AWS space configure and install the command line tools. And typically that will set it up for all of your programming languages because they're typically going to read from the same files. And you might say, Michael, what files are those? Well, if we go into your home directory and we go to a .aws directory, in here is a credentials file and a config file. If we do, I don't even know if Cat is here actually. Oh, Cat is there. Here's the config file. I'm not going to do the credentials file because it's going to show you all my keys, which I don't really want to have to replace. But just know the access key and secret access key are inside that file. So if you look at the path here, I'm at .aws inside of my home directory. And in here are two files that you care about, which is the credentials and the config file. That providers.tf file, that's a Terraform file. Just ignore that. I added that in there for my own edification. But just know that credentials and config are what you want to use. By the way, when you run AWS configure, sorry. Oh, what are you doing? It will automatically put the access key and secret key inside the credentials, and it'll put this information inside the config file. So just know when you run AWS space configure to set up your command line space, it'll automatically set the files up for you, including the directory and everything else. So the .aws directory, and this works on Mac, Linux, or Windows, is going to be automatically created for you, okay? But that's it. Get a login, install your development environment, install an SDK, and then set up your credentials. That's it. Number 4 probably being the easiest. Now, where does all this happen at? Well, you saw me look at IAM earlier, and IAM consists of users, of which we're users. It also consists of groups, and it consists of this concept of called roles. And roles are just temporary security permissions that you can assume. Think of this like sudo for you admins out there, or the Windows administrative elevation. You know, when you try to like, give you an example. Let's say I wanted to run PowerShell as an administrator. This little pop-up that it asks where it says, hey, you want to allow this device to make changes to your environment? That's you elevating permissions, right? So you can get over here and run Choco. If you're not familiar with Chocolatey on Windows, by the way, you're really missing out. I love that. It's like brew for Windows. I love that thing. I don't dwell a lot in Windows, but some of these tools are really nice. So just know that when a role is just a set of security permissions you can assume, right? You have to have permission, by the way, to assume the identity. In other words, if you want to become Batman, you have to be Bruce Wayne, right? You want to become Superman, you got to be Clark Kent. You want to be Iron Man, you got to be, well, Robert Downey Jr., but you get it, Tony Stark. So my point being is that the role has security information that says who can assume it as well. So to give you, by the way, an example of that, if we're back at the console, you can see where it says Spartan Sage and M. Forrester. I'm going to copy my account and I'm going to click on something called switch roles. Here's my account number. I'm going to elevate to something called M. Forrester admin. And when I switch the role, look at what happens in the upper right-hand side. I am still Spartan Sage logged into the system, but now I have assumed a new security identity called M. Forrester admin, which has an elevated set of privileges on the system. I usually don't have admin on my demo accounts. That was a fluke that you saw earlier. Usually I have that stripped off. I'm not sure what I was doing, but I put it on there for some reason. So just know that roles are security permissions you can elevate or escalate to. Roles are for temporary access only. They are not for permanent long-term access. So just an FYI. Note that every user, group, or role can have a permissions policy attached to it. What does a permissions policy do? We're all smart people here. Permissions policies grant permissions, right? They can also deny permissions, by the way, because you could deny someone access to a service and they will never get access as long as that deny is in place. So just know that users can have policies put on them, groups can have policies put on them, and roles can have policies put on them. Policies are nothing more than either allow or deny statements around permissions. So we'll talk more about IAM here in a bit, because this is really not the IAM section, right? Now, notice that there are 3 ways to access the API. There's the web console, there's the command line interface, which you saw me touch earlier, and then there's programmatically through SDKs, which you're going to touch in the labs. You can do more from the API than you can from the web console. Because remember, the web console is just calling the API. But more features are available quicker inside of the API through the command line interface and through the SDK than there are in the console. Because remember, the console, the AWS management console, is a product that team has to add features to in order to like keep up with the API changes. What can you do with the API? Everything. You can do everything with the API, like more with the API than you can with the web interface. So everything that's there, you want to run an instance, you want to delete and create a VPC, you want to add and remove a user. With rare exception, everything can be done through the API. I say rare exception. I can't think of one, but I'm sure there is one, because there's always exceptions, right? Anyway, developer tools. So you can get integrated kits. So whoever you're using, IntelliJ, whatever, they all have plugins now for AWS. AWS is 16 years old. Everybody's got them now, right? And of course, you got command line tools. Remember that tools page that we were just talking about? Here are the SDKs, but here's some PowerShell tools. Here's some AMI creation tools. Here's Beanstalk, ECS, Amplify, the SAM model, Copilot, which is used to like automate like provisioning and whatnot. And then just the standard CLI. There's other tools out here. Chime, by the way, is AWS's like GoToMeeting. It's horrible. Anyway, here's a bunch of code services. Here's the toolkit for Azure DevOps, which is used to be called like Team Foundation Server or Team City Foundation Server, if I remember correctly. Other ID toolkits like plugins for Eclipse and PyCharm and So just know that there's all kinds of stuff out here. Other SDKs, monitoring and tracing like X-Ray and CloudWatch. So it's all under that tools page that the link is actually posted there. So you should be getting a sense right now that there's a very rich and diverse ecosystem for developers. So, you know, there's programmatically is where everybody's headed, right? Just to be clear about this is that everyone's headed to a programmatic kind of interaction, because the web console is great for learning, but when you want to actually deploy things at scale, you're going to use the command line or you're going to use code. There's no way around that. Click provisioning in a web console doesn't get you to scale, it just gets you to learn, which is good. Now, when I ran the command line earlier, you saw me run AWS EC2 describe dash instances. You know, the general rule of thumb is that it's going to involve the AWS command, then the service, and let's see. So then the call, like the API, like call, like the endpoint, really the method somewhere, I guess would be the right way to say it. It's like, what are you calling, right? And so here I'm just getting my caller identity, and this basically says, hey, this is who this person is, right? You are user Spartan Sage. Notice here that they're basically have call the service, they've got the operation, and then they've got any parameters. Like if you wanted to switch, like you saw me do this earlier when I switched the region, I was like, hey, you know, I want to switch to a different region. So I just added region to it. And then one thing to note is that if you're like, well, Michael, I don't know that like that well, like you just did. How do I, what if I want to know how to run a command against STS? Well, you just type in help after the service, and it will list you all of the available operations, right, for the thing in question. So to give you an example, so ran help again, right? And it basically shows you everything about that STS assume role. And it's even going to basically show you the things that are required and the things that are optional, right? So notice that there's a role ARN, which would probably be like, for example, the M Forrester ID that I was running earlier, and then like a name for the session if you wanted to. As you get to the end of these, by the way, they do list examples. Oh, let's see. Here, by the way, is an example, if you can look right here, of using STS to assume a role. Note that this is just a single help command, right? So if you're used to dealing with a command line, you know, this is how it works. You can also set up auto completion for this if you're on Ubuntu. I think that works in Git Bash. It definitely works on the Mac. So So just remember, help is your friend. And then, of course, just know that AWS's documentation on these topics is really good, actually. No documentation, I think, is excellent because it's always a fluid living document. But in general, these are really well documented. They're usually not missing a whole lot. Here's some more of the SDK developer tools, right? Okay, let me just switch gears for just a second. Okay, what would I type if I wanted to list out all of the services that I could possibly call with the AWS command line? What would I type out here? You're like, Michael, is this a trick question? Yeah, definitely not that one, right? AWS help, right? Do note, by the way, if you just type in AWS, it's just going to throw an error, right? If you type in an AWS and you mangle any service here, like you just mess it up, it's going to list all the services. Okay. So someone tell me what the service name is if I want to, for example, find out how many relational database systems I have running. Here, I'll give you a hint. Let's say I mess it up, and let's take a guess, and let's say, is it RDS? I wonder if it's RDS, right? Let's mangle that and let's grep for RDS and see what it says, right? It doesn't really say anything. So let's go take a look. Well, guess what? RDS is listed here. So perfect. So let's say I want help running RDS and I type in RDS. Out of these options, which one do you think will list all of my available RDS databases? Just take a guess. You don't have to, there's no right answer here. Just take a guess. Which of these commands, these operations, do you think will list all of my available RDS databases? Good. Perfect. All right. With that in mind, if I wanted to create a database, which operation would I put here? Right. Remember, RDS instances, which you may not know this, are actually based off of EC2 t-shirt sizes, meaning they use EC2 instances that you can't log into as the underlying unit of capacity. So you have to size an RDS database based on the size of a virtual machine. So creating a database instance is exactly the right thing. My point being is that even if you don't know anything about it, you know what delete does, you know what create does, you know what describe does, right? You know what modify does. You probably guess what failover does, right? Promote, reboot. I didn't even know there was a reboot DB instance, actually. That's funny. In other words, you can figure out what some of this stuff does. And there's also always the documentation. So, obviously, if this is production, you probably want to read it first. Good. All right. Thanks for playing with me. I just want to make sure you saw the command line. Okay. Here's the thing also that you need to know. If you are connecting to like the API, there's a couple of different options. So you can connect to the service using the service client API, or you can use the resource API. Let me just say this. Actually, let me put both of those on there. The SDKs usually have robust support for the support, like the one on the left, the service client API. So support for the resource API is pretty mature in like Java, Python, .NET, but it may not be super strong for, say, like Go, which is a relatively new language, right? And you might say, well, Michael, what's the distinction? Like, I don't understand what the difference is. Well, here's the difference. So the service client API basically represents a set, as an example, as a set of client classes. This is going to expose a direct mapping of the AWS services underlying API. The client objects, let's say, for example, DynamoDB has a method for each operation that the service is going to support. So you're going to have a method call that you can make for each operation that the service is going to support. So like some of it, by the way, there's other objects that can represent request parameters that can represent like response data, because you're going to make a request with some associated parameters and you're going to get a response, right? And that's going to be a response object. So this is a low level client on the left-hand side. It's going to give you full control over the requests that you make to the service. So this is going to allow you to tightly control behavior, tightly control performance of your calls to AWS, right? So for example, Java and .NET both have an Amazon service class, client class that corresponds to each service. So there's an Amazon DynamoDB class. There's an S3 client class. So it's like Amazon S3 client, DynamoDB client, RDS client, EC2 client. These are low-level service client APIs, and you are able to granularly call every single operation you want for a service. A lot of control, a lot of granularity on the service client API. Some of the SDKs, such as the SDK for like Python, as an example, has higher level APIs called resource APIs. So what this does is it's higher level abstraction than lower level calls. And the resource API consists of classes representing each of the conceptual resources that you interact with when you use a service, right? So these classes are going to expose methods to retrieve data about the resource, invoke actions that can be taken on the resource, and retrieve links to like other related resources, right? These resources, by the way, could be service resources such as like S3 or SQS, or individual resources such as a bucket in S3 or a queue inside SQS. So like, for example, the S3 service resource exposes methods to perform actions on S3. The S3 individual resource as part of the resource API will be able to allow you to talk directly to the specific object in question. Resource APIs in general on the right are easier to understand and more simple to use as they provide a higher level abstraction. So service client APIs, just like infrastructure as a service or PaaS or whatever, give you more control, right? But you might have to orchestrate a little bit more in order to get that to function. Resource APIs are higher level abstractions. You don't necessarily get as much granular control unless you really want it, but it enables you to call these objects and execute them easier to use. As a general rule of thumb, AWS wants you to use resource APIs. This is the preference. So again, you can use both. You can use the service client or the resource API. Again, usually has support for both. Here, by the way, is an example. Let me move this out of the way. Of connecting to a service. So here we're listing objects in a bucket using the client API, the service client API. Notice that what they're doing is they're defining list clients. And here we're calling Bodo client as S3. And then we have the response, which is basically my bucket for content and response. Last modified is what they're returning. They're going to return this. So they're basically going to print out the key and then last modified. Here we're doing the same thing, except instead of list client, notice it says list resource, but I mean, that's just an arbitrary definition. They could name that whatever they want. Notice here that instead of S3 client, they're just listing S3 resource. Again, Bodo resource, right? And then they're just calling the object in question. Now, does that look remarkably similar? It does to me, right? But note that I don't think that's a great example for how complex service client APIs can get compared to the higher level abstraction that the resource APIs can get, right? So just know in general, they're going to want you to use the more abstracted resource APIs to define the service as an object and execute it that way, instead of doing low level calls across both the object, its parameters, and its responses. So yeah. But to give you an example of just the distinction of like, obviously Bodo 3, which is the Python library, has both the client and the resource API calls inside of it. Okay. So the bottom one is the preferred one. Now, in addition to having security information and deciding which kind of API you're going to use, which in general, like the resource API is preferred, you generally want to specify the region that you're going to function in. Now, I got to tell you, if this is already specified inside your config file because you defined it inside of AWS configure, which is the command line tool, then this has all been done for you. And you can still specify it inside your code if you want to, right? But like, just know like Python and Java and whatnot will actually read out of the .aws/config file. Just so you know, if you do not define your region in your code somewhere, by default, it's going to read this config file. If this config file doesn't exist, it's going to check the EC2 instance and see if it can identify what region the EC2 instance is in. This is called the instance metadata, and you can read that right off the wire, and it will operate out of that region, if that makes any sense. The AWS service will also return things like 400s or 500s, right? General rule of thumb is that if you're getting like a 404, right, then, you know, the bucket you exist may not exist, or you may not, you know, maybe 403, you don't have permissions to it, forbidden, whatever, right? If it's a 500, then you probably want to retry the application. But if you're getting 400s, you need to tell your application what you want it to do with those errors, right? But if you're getting a 500, that means there's something wrong on Amazon's side typically. Either the service is down or whatever. So you're going to need to deal with that. So just know that like Java and the .NET.SDK are going to throw like standard kind of unchecked exceptions when errors occurred. So you're going to get like com.amazonaws.com service exceptions, and you're either going to get service exceptions or you're going to get client exceptions. Obviously, if it's the client exception, the error occurred in the code, your code, or whoever's running the code. If it's a service exception, then it's going to be on the service side, right? The .NET does the same thing. Bodo throws the client errors, right? In case of client errors. And then JavaScript, JavaScript is a little different, right? The callback, like each service method that sends a request can accept a callback. So you can like send it and then accept a callback as the last parameter, and usually has like a signature attached to it. This callback is called when the response or error data is available. So you have to kind of look at the JavaScript information to see like where that shows up in the callback. So you know, nothing non-standard here. This is pretty standard actually for this kind of access. So other than just knowing about the difference between the service client, resource client, knowing about access to the CLI, the access keys and the secret keys, and then of course, knowing that you need to specify a region, that you need to be able to handle both client side errors and what you're going to do with server side errors. The other things to note is that there are a couple other tools. So Amazon has an integrated development environment called Cloud9. It actually existed outside of AWS. They purchased them. If you come out here and take a look at them, we still in Oregon? Oh yeah, hold on. Let me switch back to my previous role. Oh wait, we're still in Ohio. Let's go back to Oregon. So, oh, look at that. I don't think you were still open actually. How weird. Let me go ahead and delete you because you should be deleted. Oh, wait. Note to self, type in delete. So here, by the way, this is a Cloud9 environment, and notice that this box is shut off because you can actually set it so that it auto shuts off every 30 minutes if it's not used, which is actually pretty cost effective. It's kind of nice. So here what's happening is that this is just a plain standard Cloud9 environment. And notice, I don't even know how long it's been, but like within 30 seconds, the system will boot and be ready to go. Less than that, actually. And notice down here, I've got a terminal. And then over here are any files that I have copied or, anything that I've done here, right? And so, standard stuff should be on here, but like this can be, set up to run however you need it to, right? Java should be on here. The AWS CLI should be on here, right? So, which it is. You can add tools to this. So this can be a full integrated IDE. Now, I don't think this is nearly as good as VS Code, but it does have like, different tools, and you can add like macros and debuggers and stuff to this whole thing. I haven't invested in this enough to really love it. I do fall back to it whenever I need to get access to an environment. I don't have my laptop or I'm on somebody else's PC. I do actually have one in Ohio that is all set up and ready to go for me. It has like Kubernetes tools and all this other stuff on it. So I'm a fan, but I got to tell you, VS Code or PyCharm or IntelliJ just are so much more powerful. But just know that they do have it. And in a pinch, it is a great IDE. It's really simple. It's like Atom or Sublime. It's easy to use. So Cloud9 is basically just an integrated IDE environment, and you can pick the size of machine you want to run on. So it really, and you can actually collaborate. So like I can share my screen with other people in real time. They can log into the box and we can like code at the same time. So it's good for distributed pair or mob programming. So yeah, it's nice. I like it. But again, it's not my primary. My primary is going to be VS Code, right? That's where I'm going to spend most of my time. Huh? Okay. What was I doing over here? Anyway, didn't matter. Distraction. Okay. One thing that's cool about this is that you can clone cloud repositories. It integrates nicely with the entire environment. You don't have to worry about setting up permissions. It's going to run as the user who starts it. You can actually give it different permissions if you want to. So you get a lot of control and integration with Cloud9. So you can set up projects quickly, code together in real time, integrate with Code Guru and Code Profiler and all the other stuff easily. Serverless applications are really quick and easy to do. Like I said, I like it. I'm used to VS Code, but the editor has all this cool stuff in it. So again, it's worth investing if you don't already have a solution, or you need a fallback solution in case like something goes wrong with your environment, either because you got flaky internet or maybe you're on call frequently for a project. That's a really good use case for it. So just know. You can like set up whatever runtimes you want. Notice there's a huge set there. You can also add runtimes if you want to. So like where we were before, right? If you go into you can actually set up your build systems, set up like different configurations, run with like whatever. If you want to add a new runner, you can do that as well. You just need to basically just set it up. Very similar to Sublime, which I think I mentioned before. You can preview a running application. I don't know. There's just cool stuff. There's all kinds of settings in here too, by the way, if you like want to modify your code editors or your formatters or whatnot. You can also do things like change your security settings if you want to change, like not use the AWS managed credentials. There's a lot here. I just showed that. Now, that was all Cloud9, cloud-based IDE. Simple, easy to use, straightforward. X-Ray is a little different because X-Ray is basically an end-to-end kind of service mapping tool that will also show you like any kind of performance errors or challenges. It'll show you like performance bottlenecks. It'll give you a service map to show you end to end. Let me get you a good picture of this because it's actually pretty nice. So for example, it'll throw out little Oh, that's cute. I didn't even know that was there. That's funny. That did not turn out as good as I wanted it to be. Let's pick out one of the standard ones instead. So this is a standard kind of service map. And I'm going to blow this up just a little bit. Are you going to blow up or are you going to get smaller? You're going to get smaller. That cracks me up. Stop. So what will happen is that it'll create an interactive service map, and this will actually show up under CloudWatch. And this map will be fully clickable, and you can actually like this shows Lambda, this is Beanstalk, here's SNS. Notice that it's showing the average like transit time through the service. So 11 milliseconds, 570, 443. And then notice whether it's green or whether there's been some failures or some warnings. That's what X-Ray does for you. It allows you to see end-to-end the performance of all your services inside of AWS, from the client all the way out to your backend services. It's awesome. Great for service maps, great for identifying errors and bugs, performance bottlenecks, right? And you can build your own visualizations inside of CloudWatch. You can trace the requests, and you can do it by segments or subsegments, which, by the way, does show up in the exam if you haven't ever taken that. But it basically, you record it into what they call traces, which is basically just a user session. And you can do it by segments, like front end, back end, or by service, which is usually a subsegment. And you can see like the trace data, metadata. This is all based on open trace, for those of you who are tracking the CNCF, the Cloud Native Computing Foundation. And it allows you to drill into the services that are failing. This is another example of a service map. Notice that there's some throttling going on with both recognition and the DynamoDB table. Recognition, by the way, is used to do image recognition for AWS, image and video, actually. It'll do video, anything images. So Billy, so CloudWatch is for metrics of AWS services. CloudTrail is for all the API calls that are made against your AWS account. Those are not performance metrics. Those are more like who did what when. So they're more like security metrics, right? That's what CloudTrail is for. So don't get me wrong, you can get metrics out of that, like how many people tried to log in and failed, how many people ran a deployment and failed. But CloudWatch is for performance metrics. CloudTrail is more for security metrics. X-Ray is granular, low-level performance information in real time about a single application and its workflow. Whereas CloudWatch will track every single resource you got in your environment, right? CloudWatch is just a general metrics tracker. X-Ray is a specific deep dive into an application. Let's see, can you send, Antonio, does X-Ray work as a debugging service? In the sense of like, if it throws errors, yes, but it's not going to give you like debug level information. Like, in other words, if your application is emitting errors, they'll show up in X-Ray. And so you can definitely use it to debug and track. Like, as you can see here, if that yellow in the Lambda function was red, if you clicked on it, it would show you all the errors, like a New Relic or like an App Dynamics would. So it does actually give you kind of application performance management information. But I can't answer a yes to that, Antonio, because I don't know what level of debugging you're looking for. X-Ray will only go so far. So I think you'd have to test your use case. Yeah. But I guarantee if your application is going to throw an error, it'll show up in X-Ray and you can dig into it. So, but if you've used New Relic, for example, which is a third-party service, it doesn't go to that level of granularity. Not yet. Excuse me. It will. Give it time. They're getting there. So do you know that X-Ray will need to be run in your code in order to like get access and integrate with other services? You know, if you want a full end-to-end trace, then you've got to import the X-Ray libraries into your application, particularly for the different like services that you're using. Notice that the software listed there is pretty much everything that's listed has the general SDKs. So, And you can do things with X-ray, like for example, put trace segments, get batch traces, get a graph if you want to. You can get summaries of traces if you're looking for it. So you can see what traces are available for your application. Traces, X-ray in general writes to a subset of CloudWatch under the service map, but it is kind of like its own service. It just doesn't show up in the console typically as an independent thing. Although I heard they changed that. So hold on, let's go take a look at that. Is X-ray now listed as a separate service? Ooh. I knew they were going to change it, but I didn't realize they were going to get to it. Yeah, they did. Okay, good. So now they actually have it listed as its own section, which is great because it used to be underneath CloudWatch. And so here it is. Perfect. Instrument your application in your favorite language. Here, by the way, is just you installing the X-ray SDK. Here you're adding the middleware. Here you are running the daemon in question. Here it is on Windows. All right, so cool. Yeah, so they added some more functionality. That's perfect. And so in other words, they walk you through really simply how to instrument it into your app. So notice there's a couple options. So if you're running a container, by the way, notice this is where you actually put it as part of your Docker file. Here it is in Beanstalk. You just need to enable X-ray equals true. If you're using Lambda, by the way, it automatically enables it when you enable tracing on your function. So if you're using serverless, you just have to enable tracing. That's all. So things tend to be a little easier inside Lambda, just the way it rolls. All right, so that was about Cloud9 and X-ray. Cloud9 is an integrated IDE, cloud-based. X-ray is a tracing service end-to-end for your application. Now, other things that people typically ask is, what about CloudWatch and CloudTrail? Well, let me restate what I said earlier, just in case that wasn't clear. CloudWatch is about metrics. Now, don't get me wrong. It could be log metrics. It could be alarms. It could be dashboarding about metrics. It could be alarms about metrics. It could trigger events about metrics. It could be you wanting to get A/B canary insights around metrics. But remember how I said earlier that some of these services are tricksy because they're like meta services? Let's go take a look at this for just a second. CloudWatch is all about metrics, right? But be mindful that CloudWatch is a meta service, meaning it's got like 11 subservices underneath it. Let's take a look at these. First of all, there's just metrics, which isn't even really listed here, right? There's metrics. Then it's got logs, which has log insights and log grouping and stuff like that. Then it's got alarms, which is just plain alarms. That's just easy. Then here are the X-ray traces. This is where X-ray used to live by itself. Notice that the service maps and the traces are still listed here. Notice that I don't have any traces running in Oregon, right? I don't have any service maps running in Oregon. Maybe I should set one up for you. Actually, you know what? I'll set one up for you so you can see it while you guys are doing the lab. Here are the rules, and here's the event buses. I just want to tell you this. Events is so powerful inside of CloudWatch that it's now being extended to its own service called Event Bridge. This is basically where you trigger events based on metrics, or you receive events from third parties that trigger responses, right? And there's application monitoring, which has a bunch of stuff underneath it, including Canary. I don't even know what RUM and evidently is. They are adding new services all the time. RUM, CloudWatch RUM, end users, performance and reliability. See, they're adding new stuff all the time. And then evidently, I don't even know what evidently is. I've never seen that before. These others I all know. Experiments, features, and launches. Incrementally release new features or test features. Wow. Like I said, meta service. And then insights I'm familiar with. They got container, Lambda, contributor insights, and application insights. That's just really just like how are users performing, for example. So like if you were in Lambda, you're like, hey, I want to get some feedback on the performance monitoring. What are my function costs? Like, I want to see all the details of my app. You can do that for containers. You can do that for Lambda. You can do that for like contributors for doing your performance or application challenges in real time. And then applications is just like you instrumenting your own applications, right? You have to have the SSM agent installed in order to see that working. SSM, by the way, is Systems Manager. which is used to manage EC2 instances. Good times. So my main point in showing you all this was that CloudWatch is the metric service, and it has a bunch of variations on how to manage metrics, display metrics, respond to metrics, trigger responses to metrics, get A/B performance testing for metrics. It does it basically for systems to applications. So CloudWatch is the metricing system. That's what you should walk away with. Note, I said before, I hope you remember me saying this, that there's a trifecta of managing virtual machines with CloudWatch, auto scaling, and elastic load balancing. So you got to remember that these three will work together to send metrics, trigger responses, and register new boxes. If you are not using this for your virtual machines, you're probably using virtual machines inefficiently. It's a pretty fair statement. But these three can work together to trigger responses based on metrics against the system. Now that's all CloudWatch. CloudWatch is for metrics. Metrics of AWS run resources. CloudTrail is a security tool. People get these confused all the time. CloudTrail is a security tool. It is not for metrics. Don't get me wrong. It can provide security metrics, but CloudTrail is used when you want to know what people are doing to your account. That is a security problem. That is not it's not really a performance issue, right? CloudWatch is for performance, CloudTrail is for security. So for example, if someone comes in and deletes your primary database off your system and you're like, who did that? CloudTrail is your friend, right? Here's an example. I want you to look at this and tell me the name of the user who did something. You've never seen this before. What's the name of the user? Right, Alice. Now, first of all, we're not gonna hunt Alice down. What if someone was impersonating Alice? We don't know, right? Not only that, what if it was an honest mistake, right? How many times have you accidentally deleted something in production? Hopefully everybody who's ever worked in production at least one time has made a horrible production mistake, because there's nothing more sobering than that icy hot feeling of realizing that you just deleted something out of production that shouldn't have been touched. Good times. Anyway, so who made the requests? All right. Now, tell me what they were touching. What did they do? They did something to an AWS service. Look at this thing and tell me, just based on a guess, what did they mess with? All right, Anthony, they stopped an instance. Good, they stopped an instance. Good, I like that. First of all, where was this instance? What region was it in? Someone tell me. What region was this in? You've never seen this file before. I bet you can tell me, right? Now, how do you know, by the way, they stopped an instance? Where is the specific event that said stopped instance? Where is it? And what does it say? Good, good. What's the ID of the instance that they stopped? It's in here at least twice. Good. Perfect, right? Because you can actually see it. Let me just highlight that in case somebody doesn't see it, because it's your first time seeing this, right? So here's an instance ID. Here's another instance ID, right? Here's the event name. Here's the stopping. Here's what it was doing before. It was running, right? That's what it was doing before. Here's Alice's username. Here's Alice's ARN, Amazon resource name, right? Is there anybody who does not understand this information? Because I really want to know. Good. Okay. This is, by the way, from where, and this is when, and by the way, they use the EC2 API tools. Whoops. Which, by the way, would be the command line tools, right? And then what was the response? Well, the response was they were like, okay, we're going to stop it because you have permissions to do it. So this is all CloudTrail. CloudTrail is a security tool. You're like, Michael, why do you keep saying that? We heard you the first 3 times. I know people get confused, right? It's a security tool. That's what it is. By the way, you can like, this is like, if you want to see events, you can actually see the events in the view detail. So you can download the raw logs. You can dump them to S3. You can also just look at the events inside the event history if you want to inside CloudTrail. Notice that, here's the same thing. By the way, it's a test user. They got access denied when they were trying to list a bucket. Looks like an API call. Looks like they were using the Bodo core. So they were definitely using the command line. You can see that from the user agent, by the way, right here. Are we grokking this? Grokking. What was that from? Is that a Robert Heinlein novel? Where you grok something and you could absorb it into your being, right? Is anyone grokking this? If you're not, ask me now, because I really want to know. And your question is probably going to save about 5 other people who are not asking the question, because for some reason we get weird about looking like we don't know stuff. And do we not work in an industry where we just don't know most of the things that we encounter? I don't know about you, but I've been working with cloud for like 10 years, and I just saw 2 new services I didn't know anything about. So if you're walking around feeling like you know everything, I'd like to be your friend, because it's not imposter syndrome. It's impossible for us to know everything nowadays. So your questions are probably going to clear up somebody else's confusion. So if anyone has any questions about CloudTrail, please let me know. Cool. Good. Okay. So that was all about CloudTrail and CloudWatch. And that is the end of our section here. Knowledge check. All right. Okay. So for 1,000 points that are absolutely worthless, but tons of fun to have nonetheless, kind of like Bitcoin back in 2013. Who knew, right? The service client APIs provide a high level abstraction than the low level calls made by clients. Is that true or false? Are the service clients, are they higher level abstractions than the client calls? Is that true? Wow. Okay, good. Some of you were paying attention. I'm not even sure I was paying attention. No, I'm just kidding. Yeah. So remember the resource calls, right? They're higher level. The service client is definitely not a higher level abstraction. So the resource APIs are going to provide a higher level abstraction than low level calls made by clients. So that's false. So dead on. Okay. Riddle me this. Can you use CloudWatch to monitor CPU, disk IO, and network throughput? Can you do that? Is that what it was designed for? Yes. CloudWatch is all about metrics. If CloudWatch is not designed to do this, then we have failed, because it was designed for metrics. Okay, so that's true.
I have a quick question on the first one.
Go ahead.
Now, both systems or services has the word client in it. So couldn't that be like more trickery? You have service client and then you have clients, which I'm thinking resource clients, true, but they both say it's clients. So when you just say made by clients, it's kind of like, okay, I know there are 2 of them, but service clients or resource clients versus just clients. So when they said my clients, it just an automatically default to say resource clients.
Well, let me ask you this, Earl. If I say that service clients provide a higher level of abstraction than any other client call, what would you say to that?
Any other client call? Yeah, I would say false to that.
Right. So if it says service client, then you automatically know that it's going to be the low level call, right? I agree with you. I think it could be clearer. I think it should say by resource clients as contrast. I agree with that, right? But we don't need that level of clarity, because we know that the service client is the lower level abstraction compared to any other client call we could make. But it could be clearer. Does that work for you? Or because you know what I mean? Yeah,
but
you're right. It
it's
could
the
be clearer.
engineering here. Is the engineering in here wants to be specific about things.
And you're right. It's not specific. It should actually say made by resource clients. I totally agree. So, and the only reason I say that is that I've sent several emails about making sure that they are clear with that language. So they know there's a new version of this class coming out in 2 months that fixes that problem. So 4.0 coming out. Yeah. The devil's in the details, right? So the specifics make a difference. Okay. You may have seen the answer just now because I clicked on it on accident. So if you did, don't answer. All right. X-ray can tell you who made a call and what they requested. Now, does this sound ambiguous? Let's clarify this a little bit before you answer. Hold on. Wait. Amazon X-ray can tell you who made an infrastructure call and what they requested from the infrastructure. That's what that box actually should say. And in 4.0, that's exactly what it will say. So if I say infrastructure call and what they requested from the infrastructure, is that now a true statement or a false statement? So I see those of you have posted, right? X-ray can tell you who made an infrastructure call and what they requested from your AWS accounts. Well, actually that would change it because X-ray doesn't do that, right? What service would I use if I wanted to know if someone stopped an EC2 instance or created an S3 bucket? What service would I use? CloudTrail. That's right. I would use X-ray if I wanted to know what someone made an application call and which of the applications that make up that application call caused a slowdown for the user. That's when I would use X-ray, right? No, X-ray can drill down, Anthony, as long as it's surfaced by the application. So it's not just an aggregate. And now, again, just to be clear, it won't go as low as like a third party, like a New Relic, not yet, but it'll go pretty low, right? But it won't like run the test calls and run synthetics for you. It won't do that. Okay. True or false? A 500 series HTTP error in the code indicates how to handle the error in the application. Yeah, I think we all know that. 500 errors are server-side errors, right? A 400 series error is a client-side error, and a 500 series error is a service error. That's a their problem. Like I joke, it's like if it's a throwing a 400, it's my problem, or it's my problem with them. If it's a server-side error, it's their problem with me or their problem, right? So just know, right? So that's false. Okay, true or false? You can actually call the AWS API directly using the SDKs or the command line, or you can use the management console. Are those all legitimate ways to interact with AWS? Cool. That is true. By the way, there's others like the software, the cloud formation, the software, the CDK, the cloud development kit, Amplify. Oh, there's so many different ways to access AWS. Sometimes there's too many ways. Let's refer to Exhibit A around having too much information in the IT industry, right? Wouldn't it be great if there was only like 3 ways to do something? But that would drive some of us happy and some of us mad. Be like, I really want to do it this way. I want control over my own way of doing it, right? So. Okay, does anyone have any questions about anything around CloudTrail, CloudWatch, X-Ray, Cloud9, any of the like the SDKs, the errors, any of these pieces, the service client APIs versus the resource client APIs? Any questions about that? Oh, Antonio, so yeah, let's go back here for a second. I don't know that I have a slide for that. Pardon me for bouncing around for just a second. Let's go to X-ray for a second. All right, so actually we did have a great slide in here about showing, there it is. All right, so here's how this works. So can you talk about load balancing, auto scaling, and X-ray? So here's what happens is that once your application, which is sitting in the middle of that on the auto scaling group. So assume those are EC2 instances, and you've put X-ray in your application inside those EC2 virtual machines. So what happens is that all that tracing information, it will automatically talk to the AWS services and put that in, has information in the service map. Now, I want to be clear about that, is that if those metrics aren't being surfaced because you haven't turned on detailed monitoring, or you're not running the SSM agent or something else, sorry, the X-ray agent, not the SSM agent, the X-ray agent on the system, then you're not going to get those metrics. You have to turn them on, right? Most of the time, by the way, they're on by default, but if you want more detailed metrics, you have to enable that. But X-ray is going to aggregate all those metrics to give you all the information it can about your application from the moment of entry to the like back end all the way back to the client. So it's not necessarily going to surface load balancer metrics unless the load balancer is a problem. Right? And the load balancer. So sometimes the service map is not fully complete for services that it thinks are just kind of like an afterthought, like a load balancer should be an afterthought, but it will allow you to click into those metrics and take you into the CloudWatch metrics to see them. But the only thing services here that you really need to pay attention to that have metrics associated with them are the auto scaling group, because they have virtual machines in them, and the load balancer. So you'll see that show up in the service map, but you'll have to click into them to get more information, but it'll tell you if there's a problem there. So that's how load balancing, auto scaling, and X-ray will kind of work together. Because again, the only services here you have to pay attention to are the virtual machines and the load balancer. If you have an associated database, it'll show you that. If you have S3, it'll show you that. Like, it'll show you the other associated services, but it'll all show up on the service map for you to click on. So that's how those interact with each other. I will tell you that auto scaling is independent of X-ray. That being said, let me make this very clear. If you want CloudWatch to trigger an alarm and therefore cause auto scaling to respond to an X-ray performance metric, you can make that happen. So in other words, because X-ray metrics show up inside CloudWatch, you could say, hey, if X-ray says that overall application performance is less than 300 milliseconds, and I don't like that, I want you to increase the EC2 instances, you can get auto scaling to respond to that. But I just want to tell you is that in general, you want services to scale based on specific metrics about those services. In other words, I don't want to increase the auto scaling group unless the virtual machines are suffering. If the load balancer is suffering, that's a different problem. If the DynamoDB database is suffering, that's a different. Hi. So let me continue. So basically, bottom line is that you want metrics to trigger auto scaling based on the service in question. So this particular auto scaling is for virtual machines. DynamoDB has its own auto scaling capabilities. Kinesis has its own auto scaling capabilities. Some of these systems all have their own auto scaling capabilities. So you wouldn't necessarily use the X-ray metric, but you could. So just make sure that I throw that out there. Just to say that is that you could use the X-ray metric if you wanted to. Okay. Now, there was another question, which I think I just lost. Could someone repeat that question that just popped up in the chat? Because for whatever reason, Zoom doesn't keep chat history and you lose it immediately. There's another question here. Oh, can we touch on client resource again? So Justin, yeah, so client resource. Okay, so when you call the SDKs, there are two ways to there's like in a sense, two methods that you can call here. One is basically a high level abstraction, which is the resource client. That's the one on the right. That's the one on the right. You can call either a high level abstraction or you can call a low level
Can you
abstraction.
just share your, we can't see the slides currently.
Oh God, thanks. All that got reset. Thank you for saying something. So you can see a high level, right, which is the resource API, or the low level. And so what they're advocating for is they're saying, look, if you have an SDK, which by the way, will clearly tell you whether it has a high level or a low level abstraction, they want you to use the high level abstraction. In other words, they want you to use a resource client API call instead of a service client API call. Service client is where AWS started. They were giving everybody low level access to granular level, highly controllable, very explicit calls. And AWS came back and said, you know what? People don't want that unless they need that level of control. Maybe they just want to call an object and automatically get responses for it and not have to separate like an object for the call itself, its parameters, and its response, right? They want to simplify that whole process. That's what the resource API is for, right? It's just to simplify that process of how we interact with AWS. So in general, they want you to use the resource API and not the service client API.
Okay, thank you.
Yeah, perfect. Good. Okay. Good questions. Anything else that anybody wants to talk about around just kind of adjunctive developer aware services? Okay. I'm going to spend 15 minutes talking about IAM. We're going to pause. We're going to go to lunch. Then I'm going to finish out IAM. I'm going to get you an introduction to the labs. We're going to talk about S3 and developing with S3. Then we're going to do a lab. Then if we've got time, we're going to do a lecture on DynamoDB. And then we're going to do a lab on DynamoDB. I just want to be aware, though, that the only thing that we really have to finish today is S3. So as far as pacing goes, we're doing great. Okay. Okay. Let me stop this.